graphing y equals minus 2 tan, open bracket, x plus pi over 4, close bracket. The general tan function equation is y equals a tan, open bracket, bx minus c, close bracket, plus d. It's always good to know the parent function of the function you're plotting. The parent function y equals tan x has one pi period. That means every pi it repeats its period. And so it goes from minus pi over 2, 0 to pi over 2. And that's the parent's function. So in this function here, we've got the amplitude. Number one factor is to look at the amplitude. So the amplitude is none, because the graph goes all the way to positive infinity and negative infinity. Number two is to look at period. The parent's function has a period of 1 pi, and then it repeats again every pi. This graph has a period, and period is pi over b. And b, in this case, b is 1, so the period will be pi over 1, and that equals pi. So this function also has a period of every pi. Number three, we need to look at x scale. So I'm choosing 2 because we have 2 line of asymptotes. So I'm going to divide a period with the x scale. You get a period you just got, and period, and you divide it by 2, and that will be pi over 2. But you can also write that, remember, as 2 pi over 4, which is still 90 degrees. Number 3 is, do we have phase shift? Phase shift, let me just write that. Yes, do we have phase shift? Right, so we look at the start. That's when we set like here we set x to 0. And that's how we get that x equal to 0. Well, we haven't got x, we've got x plus pi over 4, so we have to set x plus pi over 4 to 0. And therefore, x equals minus pi over 4. So that's our phase shift. And the next thing is, do we have, number 4, do we have vertical translation? Yes, it's 0. So it's plus d. D is the vertical translation, and that's 0. So that means y equals to 0. So that this is why this one here is y equals to 0, because it's the x-axis. And the vertical translation here is 0. That means it does not translate. It's just staying on the y equals to 0. And number 5 is, do we have any reflection? So number 5, do we have any reflection here? Here there's no reflection because A is positive. Here A is negative, so there's a reflection, yes. Reflection about the x-axis due to the minus. What is the 2 doing? The 2 is just basically making the graph skinnier. So it's just slim the curve a little bit. And if it's been multiplied by a half, it will make the curve broader. So, but the reflection is about the x-axis. Right, so we have got the starting point. The starting point is the phase shift here, which is minus pi over 4, 0, this is 2, this is pi over 2 from there to there, so minus pi over 4 is here. So that's where the curve starts. And then I need to add, because that's what the period is the scale is telling us to add pi over 2. But because I've got pi over 4, I want to keep pi over 2 the same base denominator as pi over 4. That's why I multiplied that by 2, to keep it the same denominator, so it's easy to add. So I'm going to add pi over 4 with 2 pi over 4 minus pi over 4 plus 2 pi over 4. Well, all I need to then do is add the numerator, right? So minus pi over 4 plus 2 pi over 4 will just be pi over 4. And here is pi over 4. Because that's 2 pi over 2, that must be pi over 4 halfway through. Okay, so that means this is it starts here, and the line of asymptote is going to be here. So that's the line of asymptote. So the line of asymptote here is basically, I could call that pi over 4. And this is where the curve starts. Now I need to add another pi over 4 to the left, but that means add minus pi over 4. If I have minus pi over 4 here, I need to add another 90, well in this case minus 90, so that will be minus 3 pi over 4, because minus 2 pi over 4 plus minus pi over 4 will be minus 3 pi over 4. That would be right here. So it's going to be right there. So this is minus 90, so that's minus 3 pi over 4. And I could write it here, so that's minus 3 pi over 4, because I'm adding 90 from there to there. So that's 90 anyway. But remember, this is minus pi over 4. So I have to add minus 90. That minus 90 is minus 2 pi over 4. The line of asymptote again, so just draw that line. Right, so the curve is going to go, so because there's a reflection, naturally the curve goes from the negative infinity to the positive infinity. Now it's going to be reflected up, and this will be reflected down along the x-axis. So it will be starting from here. So let's use a red pen for that. Right, so it'll be starting from there, and it'll be coming down all the way there and approaching there. So that's what's going to happen. So it'll be coming there. Right, so that's what the sketch is going to look like. So it'll be coming from, if you like, positive infinity to the negative infinity here. And that's the sketch. This is a line of asymptote. So the line of asymptotes are minus 3 pi over 4 and pi over 4. We could sketch another period. So that's one period. If you work out that period, minus pi over 4, and then you got another pi over 4 here. If you add them together, that will be 4 pi over 4. Just look at the magnitude. So 3 pi over 4 and another pi, that will be 4 pi over 4, which is pi. So that's 1 pi. Now to draw another period, well, we've got the line of asymptote here. We need to add 90 to pi over 4 here. That's the next one here. 90 This is pi over 4. We need to add 90 pi over 2. That's the scale. It's telling us add 90 every time. So the next interception will be pi over 4 plus 90. And 90 is 2 pi over 4. That means it will be 3 pi over 4. So 3 pi over 4 is here. So this is 3 pi over 4 there. That's the next point of interception. So that'll be 3 pi over 4. So 3 pi over 4 is 135 degrees. This is 90. You're just adding 45 to that, because this is 45 degrees. 45 plus 90 is 135 degrees. Okay, so that's the next interception. So that means this curve is going to come this way through there, and then we need to add another 90 again. That's why we divided by 2 for the scale period, because half a period. So now we draw the line. So we need to add another 90. So we go from there. Another 90 is 3 pi over 4 plus 2 pi over 4 will be 5 pi over 4. So that'll be here. So that'll be 5 pi over 4. So we need to draw the next line of asymptote. So we just bring it, ruler there, and draw this hidden line. Okay, so now we go the next period. So that's first period, next period along. The graph will come that way and then goes that way. So it will be coming from there, approaching that, and going that way. Okay, so that's what the graph will look like. It's exactly a period, in this case, same period, 1 pi, but it's reflected. That's why, because of the negative. The 2 just makes the graph slimmer rather than broader. If it's a half here, if it's not 2, if it's 1 over 2, it will make the distance here broad a bit. And that's the graph of y equals minus 2 tan x plus pi over 4. So what we haven't talked about is the range and domain. The range for this graph, you can see the y value goes all the way to plus infinity and negative infinity. So the range will be, if I could write here, range are the y values. So you get y colon, it goes from minus infinity, it's less than y, is less than infinity. We always start from the lowest value. Minus infinity is lower. Then we put the what coordinate we're talking about. So we're talking about y axis, and then it goes all the way to highest value, which is plus infinity. That's how we write the range. The domain, on the other hand, is for all real values of x, except, so domain will be, so it's all real values of x, so that includes real values of x. But there is a condition, but x cannot be equal to, so you can just pick one of the line of asymptote here. So I'll pick pi over 4. So it cannot be equal to pi over 4 plus, but you're repeating it every pi, isn't it? Pi over 4 and then every pi. So then you do pi n. Because then what it meant is you cannot, if n is 0, That's pi over 4. So that's the line of asymptotes. We can't have that because it doesn't cross it. Then when n is 1, so you got 1, so that means pi over 4 plus 4 pi over 4, because I just multiply top and bottom here by 4, so that gives you 5 pi over 4, and that's 5 pi over 4. There you go. And when n is minus 1, to get this one, when n is minus 1, so you get minus pi, so you get minus 4 pi over 4, because you want to multiply top and bottom by 4. This is over 1, by the way. So you multiply that by minus 4 pi over 4, and that will be minus 4 plus 1 is minus 3, so that's minus 3 pi over 4. That's how you get that. So the domain, if it's not clear what I've written there, so for the domain, you got x all contain all real values of x, but there's a condition that x cannot be equal to pi over 4 plus pi n, where n is an integer, so where n is an integer. So that means it can be 0, 1, 2, minus 1, minus 2.